Welcome once again. We have a few more examples to consider, a few more ideas to kind of show you, to try and sell you on, different approaches to consider. And it's all with one goal in mind. I just give you all of these examples with the hopes that you'll see approaches that appeal to you and get you so many ideas that you don't just try and emulate what's being done here as far as just, okay, I see this setup, I need to do these steps. But rather, you look at it more critically, that you look at these problems, you look at these equations, and decide for yourself what needs to be done, and then do it. That's why we do all these equations. That's why I'm presenting all these equations here to kind of showcase various thought processes and various techniques that can be used to solve these equations. And recognizing that, yes, it's true that the actual solutions to these equations aren't terribly important to your success in life, but the actual underlying thought processes to be given a problem and decide what the appropriate solution technique or what the appropriate approach to take is, that is worth doing. And that's why we do it the way we do it. So let's just get right to it. Once again, just a few more quick examples, and we will round out analytic trigonometry in that fashion. So once again, just kind of reminding you here that we don't have to be fancy if we don't need to be. We can still use basic identities if we have to. We can still not if we can get away with that. So for the equation here, 2 sine squared theta minus cosine theta equal to 1. Once again, we can do an appropriate substitution there, and that would get us what we need. Right? That becomes 1 minus cosine squared. We distribute, we combine like terms, and we factor. Doing that gives us a handful of solutions, one stemming from when cosine theta plus 1 is 0, the other stemming from when negative 2 cosine theta plus 1 is 0. So cosine theta is negative 1. That happens at pi and 3 pi and 5 pi, and also negative pi, negative 3 pi, negative 5 pi. This other factor is 0 whenever cosine theta is equal to positive 1/2, which happens at pi over 3 and at negative pi over 3. Nowhere else, though. Those are the 2 places that happens. So all of our solutions then come from those things. And that's all we got to do. Now, when we have to be fancy, we do have to be fancy. So here's one example here. I've got cosecant of 2 theta equaling 5 sine of 2 theta. And yes, I probably could do some double angle formulas here, or I could just recognize that, oh yeah, cosecant's 1 over sine. Let me multiply everything by sine 2 theta. I've got 1 equaling 5 sine squared of 2 theta. Divide by 5, take the square root. I've got sine of 2 theta equaling plus or minus 1 over root 5. And that actually gives us a few solutions. I only wrote a couple there. There's a few more than that. But given for 1 over root 5, sine of that angle has to be equal to approximately 0.4636. And everything coterminal with that. The supplement of that also works, which is pi minus 0.4636, and that will do it as well. But that will get you just sine angle equals positive 1 over root 5. To go from there, you have to do a little bit more, right? We have to find the negative values as well. Do an arc sine of negative 1 over root 5, get a little bit more. But that's how it's done. And it's also just a way it's done. There's plenty of other ways. One other comes to mind pretty straightforwardly, but there are probably still other ways to crack this sort of question. So if I could say anything, it would be this. Do what you are most comfortable doing. If it works for you, it works for me. So there's actually a couple ways to crack this one. I had kind of alluded to that in a previous video, but we'll go ahead and spell it out right here. If you need to solve the equation cosine 2 theta minus cosine 4 theta equal to 0, one way to go about it is to use the double angle for cosine. So we make an appropriate substitution there. We've got a quadratic now, negative 2 cosine squared 2 theta plus cosine 2 theta plus 1 is equal to 0. That actually factors just like this, actually. Actually, no, it doesn't. That's a minus there. That's a plus there. So I think the factorization in this becomes minus, maybe? Maybe they're both minus. Or maybe you just have to use quadratic formula. In any event, we know how to handle this. We can go from there. But you don't have to do it this way. There's other ways to answer this sort of problem. You could recognize, oh, this is cosine minus cosine. I've got a sum to product formula for that exact thing. Cosine of 2 theta minus cosine 4 theta, that's negative 2 sine sum over 2, sine difference over 2. And so we now have negative 2 sine 3 theta, sine negative theta equal to 0. We can handle that too. Whichever way works best for you, works best for me. So hopefully this has been a nice kind of way of reminding you and showcasing the various approaches and techniques we now have access to. By the end of this, I hope that you have a very thorough understanding of the extent to which you can solve these sorts of equations. And more importantly, the ability you have to recognize how to solve them. That's far more important than the actual solutions themselves. But the ability to recognize how to do it. That's what I want to see. And that is it. That marks the end of analytic trigonometry. The ability to analyze a trigonometric expression or a trigonometric equation and decide what needs to be done. This is the end of analytic trigonometry. We can now solve equations with the best of them. Right, we can use function equations of these, actually, if we choose. We can make function equations and graph our solution sets. We can do all that good stuff. But that is not only the end of analytic trigonometry, but it's also the end of everything we can do in trigonometry on the Cartesian plane. Well, we can do more, but this is all we're going to do in this class on the Cartesian plane. So next bit, the next remainder of the semester, the next remainder of the course, we will start looking in systems beyond the Cartesian plane. Not in more dimensions, right? Not in 3 dimensions or anything like that, but other 2-dimensional systems and other 2-dimensional coordinate styles. And we'll see if we can redefine or redo or improve on our ideas of trigonometry in those systems. So I'm very excited about that. This is, for me, one of the most exciting parts of this course. So I'm very excited for what's coming down the pipe. Currently a circular or cylindrical pipe. But going forward, maybe it'll just be a pipe of constant radius. So I look forward to that, and I hope to see you in the next few videos when we get into polar systems. But we made it. We made it through analytic trigonometry. Job well done. Let me know what you're worried about, and I will see you up ahead. Have a good one.